Greetings. In this video, I'm showing how to convert a decimal number into a binary number. And this basically is kind of an algorithm, although it depends how you consider it. And it also depends on the size of number we consider. But basically, what I'm showing here is we have some decimal number, and I'll show with some examples how to convert it into binary number. Where decimal number, it means it is consisting a number format consisting of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And a binary number will be a number only considering of the digits zeros and ones. So the first example can be, let's say, decimal number 17. So the example is decimal number 17. And the way I approach it here, the way we do it is basically for this video I'm choosing probably the most simple to understand, more implicit way. What one does is one lists the powers of 2. Might be a connection if one thinks about it with the binary numbers. Binary meaning like 2, right? And so I'm listing all the numbers of 2 from the power 0 through power 1, 2, 3, 4 until I reach some number. I'll actually explain why it is so. So 2 to the 0th power is as any number 1. Then I have 2 to the first power is 2. 2 to the second power is 4. I continue, times 2 is 8, times 2 is 16, and so on. And actually in this case I can add end at 16. And the point here is I'll look at this number 17, this decimal number, I want to convert it into a binary number. And my objective here is to take these powers of 2 in the left column that I wrote right here and find a combination of them so that if I add these numbers in some way, in total it will give 17. But I can only use each of these numbers either once or 0 times. So what I'll do is, in this case, what kind of way we can combine these numbers, and knowing that I can only use each of them once or not at all, well, I'll have 116, I have no 8, no 4, no 2, up until 1, which I have once. And then this is basically my result. The only thing is I have to view it from the highest used power of 2 position to the lowest. So if I was writing it like this, I might read it 1, 0, 0, 0, 1. Now in this case actually it's symmetrical, so it does not matter. But as a matter of practice, it always goes from the bottom to the top in this way. So it means that we read it 1, 0, 0, 0, 1 from the bottom to the top. That means that if I write it in binary form, then 17 will go into 1, 0, 0, 0, 1. 0, 0, 0, 0, 1. Alright. And the second example, I can use a bigger number to just illustrate this with a bigger number. So let's say I have the decimal number 321. So again, I'll use this same idea. And the idea is as follows again: list numbers that you think you'll need to add up using each of them and in correct order. So from the 0th power of 2 and rising by 1 always. So the 0th power of 2 is 1, then we have 2, 3, 4, 3. Oh, actually this made it complicated rather. So just deleted this, maybe let's quickly delete this. And hopefully things will work now. So I'll just write it again. We have 321. Unfortunately, we lost the previous example, but in any case, you can skip back if you want to see it again. So now we're considering second example, number 321 in the decimal format. Now I want to convert it into binary form, and I'm using the same idea. I'm listing the powers of 2, starting with the 0th power, rising to the first, second, third, and so on. So I start with 1, then I have 2, 4, 8, 16, 32, 64, 128, 256. And in this case, you can already predict we won't need anything larger than 256 in this case. And actually 256 will get used once. So now again, as before, this is all ordered. We start with the 0th power, went to the 1st, 2nd, 3rd, 4th, 5th at the 32, 6th at the 64, 7th at the 128, 8th at the 256. And basically these are the list of powers from 2, from the 0th power through up until the 8th power. And again, I'm looking at this decimal number 321, and I want to express it as a combination of these numbers in the left column here. And I can either use each of these numbers once or 0 times. So if I think about it, I can use 256, I can use it once, and then what next big number we can use for it to stay quite simple is 64 can be used, and then we get directly almost the result. It will be 320. So I get 164. That means I did not use 128, but we'll see in a second. But actually, if I already use 64 and 256, it's clear we cannot use such a big number like 128 anymore. And then we use 1 once. So we get 256 plus 64 is 320, plus 1 is 321. So we use these 3 numbers once, which fulfilled the rule, and all the other ones we use 0 times. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. And as before, important to note, we have to read them from the last or from the bottom to the top. So from the biggest used power of 2 up until to the lowest used power of 2. So what we get is basically a number which is now not symmetrical anymore, so it's important that we use this order. And if I write it out, the result is if we converted the decimal of 321 into binary, we get namely what is seen in this column. Use 256 once, then it's 0, then it's 1, 0, 0, 0, 0, 0, so 5 zeros, and then one last digit of 1. So this is the number 321 converted to binary form. So as you see, this is very practical for these small numbers. It might be harder to estimate or look at a bigger number and see what kind of tools are used there. And then there's a more complicated algorithm or more careful one. We might get into that in another video, but it was a quick intro. Hopefully it was useful. And you can use this for practice. You can think of some other numbers and practice this technique.